Alright guys, I'm going to help you with some of your test corrections for chapter 5. These are not covering every question, but these are the ones that I noticed were missed the most. So I'm going to go all the way down to number 7 first. This one is about the brown hairs, brown eyes. And I tried to just go back to the formula we have. The probability of the OR is over here, equals the probability of A plus the probability of B minus the probability of the overlap. And it gives you the probability of BE, brown eyes, right here. Probability of brown hair, I called that BH, is 45%. We do not know if they overlap. That's the AND, which is essentially the question. Are they mutually exclusive? Mutually exclusive means they can't happen at the same time. And then they give us the OR probability right here. 60% have brown hair or brown eyes. So essentially I just put in the numbers where they go. They're asking you essentially, is this X 0? If it's 0, that means it means these circles don't overlap. But it's not, because this is 0.80 minus X equals 0.60. So X would be 0.20. So are they mutually exclusive? No, because they can happen.
Brandon Clevin to Dr. Conboy's office, please. Brandon Clevin to Dr. Conboy's office.
At the same time. Pepperoni and mushroom pizza, the word you got to pay attention to is only. So these numbers here are the only, they're not in the middle. Then it said the 15%, they don't like either one, they're on the outside. When you add all of those three up, you get 100%, which means there's nothing left for the middle. So are they disjoint? Yes, because the probability that they both happen is equal to 0. Number 10. If you start to use the notation, it'll help. So they told you the probability somebody walks to school. They told you the probability someone had been late to school, 32%. Then, this part's maybe the tricky part. This is a conditional statement. 37.5% of the students who walk, so that's my condition. So it's a conditional probability. Okay, then what's it asking me for? What's the probability a student selected will be one who both walks? So they're asking you for the AND. They're asking you for the overlap, which is this part. So then I said, okay, well, they gave me the conditional probability. So this here is just using the formula, which is on your College Board sheet, to break down this, which we know the numerator is the probability of both, and the denominator is the probability of walking. And so if you put the numbers where they go, let's see, they gave you, in this equation, there's 3 things, and they gave you 2 of them. They gave you that this one is 0.375, and they gave you the probability of walking down here is 0.40. So in fact, being late here, you don't really need that. So to solve this, you just take this times this, which I think, what is that? Where's my calculator? 0.40 times 0.375, 0.15. So B. 11, I showed my work down here. The answer is D. So again, they told you they're independent. They gave you the probability of each. If items are independent, this is true, right? If they're independent. So to find the probability of A and B, I simply multiplied 0.3 times 0.5 to get 0.15. And that's not the question, okay? What's the question? Which is of the following is a correct statement. So this one had a lot to check, that is for sure. And you could go through each of these and you could find why each one's wrong. But D is correct. If you go back to the A or B formula, which again is on the College Board sheet, that's probability of A plus B minus the probability of A and B. Well, 0.30 goes there, 0.5 goes there, 0.15 goes there, and you do this and you get 65. All right, FRQ time. The potato, chips, and apples one. Label your Venn diagram. Put 0.09 in the middle. PC for potato chips. The most common mistake was kids put 0.21 here and 0.36 here. If you do that, now look at the apple circle. You actually have 30% inside there, but that's not right, okay? It has to only be a grand total of 21. So I've got to do 21 minus 0.09 to get 12. That's what goes here. Likewise on the other side, I have to do 36 minus 0.09 again to get 27. Okay, calculator, what is the leftover? 0.12 plus 0.09 plus 0.27 adds up to 48. What is 1 minus that? Oop. Well, that's 52. So that's the people that did not buy either one, which foreshadowing, that's part D. All right, if you messed up this chart, I tried to grade yours accordingly. It made it much more difficult, but I did my best. So then the OR question is 2 ways to do it. You can just add up these 3. It's people that buy one or both. I already added up those 3 on the second line of the calculator right there, and that's 48%. You could also do the probability of A plus the probability of B minus the probability of both, and that would be 0.21 plus 0.36 minus 0.09, and that would also be 0.48. So either way, part C is probably the hardest question, maybe of the whole test. Try to put this into notation, okay? The probability somebody buys potato chips, PC, or they do not buy, so that would be the U symbol, or they don't buy apples, A with a C. So with the formula, that's potato chips plus not apples minus the probability of both of those things. PC, Peter, there we go. And not apples. All right, so probability someone buys potato chips. That's right here. That is my 36%. Probability somebody does not buy apples. So here's the apples, right? So not this. So that leaves you this and this. You add those up. 0.27 plus 0.52 is 0.79. So in other words, 79% of the people do not buy apples. Then you subtract the overlap. Where are the people that buy potato chips and do not buy apples? Let me say that again. Where's the people that buy potato chips and they don't buy apples? That's these people right here. They bought potato chips, but they did not buy apples. So that's 0.27. When you add those up and do the work, you get 88%. This was not oftenly. This was often missed on the test. Letter D, they don't buy either one. Well, that is your 52%. Okay. 2. First one is just what's probability someone's in that age category. Where's that age category? There's 89 people out of 207 people. That is 0.43. Part B is conditional, okay? For those in the sample whose incomes are over 50K. So that's the condition, which limits my sample. Well, let me write it with conditional notation. So this is the probability that someone is 31 to 45 years old, given they make greater than, I'll say 50K, okay? The condition limits my denominator to this column. So there are 96 people in that group. I have to pick from that group. Remember, conditions shrink the sample from 207 to 96. Within that orange group, how many are 31 to 45 years old? That's 35 people. And that probability is about 36%. Part C if you did part A and B, they piggyback off of each other. Because let me use the notation to remind you. I'm gonna copy this one and part A as well. Because this is true if they're independent, okay? And remember what this means. Does having this income affect the probability of being this old? A person's probability of being in that age category. And it does, because the number on the left is part B, that's 0.36. The number on the right is 0.43, just from grabbing these two answers right there and there. So in other words, being in this income bracket has lowered the probability of being 31 to 45 years old. Over here, we just picked any old person out of all 207, and the probability is higher. So that means these are not independent. And you need to explain. So you would say a person's age, a lot of you did not explain, has an impact or an effect on, oops, no, sorry, I'm saying this backwards. A person's, well, you could say it either way. I'll say it both ways. A person's age has an impact on the probability they make more than $50,000 a year. That's what it means to be not independent. You could also switch it. You could say a person's income level has an impact on the probability that they're in a certain age bracket. You could switch these, okay? That would be equally appropriate. Okay.
Miriam Dallin.